Welcome. In this and the next few sessions, we will look at examples of calculating higher order derivatives. In a sense, this is just a matter of reviewing all the rules of differentiation and applying them in proper sequence. But calculating higher order derivatives involves a lot of calculation, and efficient calculation depends on a few tricks of trade, which I will explain as we go along. Our first example is finding a third derivative of a power of the variable. If you have a power of the variable, even if it's negative or fractional power, it's no more difficult than dealing with the case of a polynomial, as long as you first write the power in a suitable form. If you have radicals, you want to convert it to fractional powers, and more importantly, if you have a fraction, you want to write it using negative exponents. So I will write 1 over cube root of t power 4 as first convert cube root to fractional power. Cube root of t power 4 is t to the power 4 thirds. Then bring it up to the numerator, which makes it t to the power negative 4 thirds. Now it's a simple application of the power rule. First derivative of t power negative 4 thirds is negative 4 thirds t to the power negative 4 thirds minus 1. Negative 4 thirds minus 1 is negative 7 thirds. If I differentiate this answer, then I get the second derivative. So the second derivative of t power negative 4 thirds is the derivative of its first derivative, negative 4 thirds t to the negative 7 thirds. Negative 4 thirds is a constant factor. I keep it as it is, differentiate t to the power negative 7 thirds, which is just another application of the power rule. Derivative of t to the negative 7 thirds is negative 7 thirds t to the power negative 7 thirds minus 1. I'm not going to do the multiplication in front because I want to illustrate a pattern that occurs in situations like this. But let's simplify the exponent. Negative 7 thirds minus 1 is negative 7 thirds minus 3 thirds, which is negative 10 thirds. The product in front, negative 4 thirds times negative 7 thirds, is still a constant. There is no variable in it. So I can treat it as a constant factor when I'm differentiating. I have to find the third derivative of the given function, which means I need to differentiate the second derivative. I keep the constant factor in front as it is, differentiate just the variable part. Derivative of t power negative 10 thirds is negative 10 thirds times t to the power negative 10 thirds minus 1. Before we simplify this, do the calculations and write our final answer, let me point out a very simple pattern here. We started with t to some power and found the third derivative. The third derivative, I have three factors in front. These are negative 4 thirds, negative 7 thirds, and negative 10 thirds. These came from the exponents in successive derivatives starting with the original function, which means I have negative 4 thirds, and then negative 4 thirds minus 1, and then negative 4 thirds minus 1 minus 1. So at each step you subtract 1. And then the exponent in the last step is 1 less than the last factor. Of course, now I can do the multiplications, do the arithmetic in the exponent, and write down the final answer. Let's use the pattern I just pointed out to do a fifth derivative this time. Fifth derivative of square root of w power 7. Again, I'm going to write square root of w power 7 as a single fractional exponent. Square root is power 1 half, so square root of w power 7 is w to the power 7 halves. So following the pattern that we just saw, I start with original exponent 7 halves times 7 halves minus 1. 7 halves minus 1 is 7 halves minus 2 halves or 5 halves times 5 halves minus 1, that's 3 halves, times 3 halves minus 1, that's 1 half. We have to do 5 derivatives, so I'm going to have 5 factors. I need one more. 1 half minus 1 is negative 1 half. Then w to the power negative 1 half minus 1. Negative 1 half minus 1 is negative 3 halves. And that's the fifth derivative of square root of w power 7. Of course, you can do the multiplications and write down the final answer. Negative 105 over 32, w to the power negative 3 halves. This concludes our look at finding higher order derivatives of powers of variables. As long as the power is a constant, we can use this pattern.